of the thermoforming process. Also, we have seen the batch type process as well as the continuous type process. We also seen their applications of thermoforming, the advantages and disadvantages. Now we are talking about the types of the thermoforming. But before that, I told you yesterday only the types of mold and and the material of a construction of a mold for thermoforming application. There are different type of materials that we have seen yesterday. Plaster of Paris, low life, hardly 10 or 20 pieces we can produce from the plaster of Paris. Then we have also seen the metals, aluminum is durable, but again some wear and tear problems. Again, wood also we can use for the construction of thermoforming mold. But wood, I told you, you have to apply the enamel there and varnishes. You can produce up to the 100 articles from that, but again it will give problems afterwards. And hence we have also discussed the plastic mold, epoxy resin, right? It is a durable, having a long life, like aluminum. And generally people are preferring aluminum, wood, and this type of plastics uh, thermoset material for the construction of the thermoforming mold. Now, I told you about the material. The material should have the different type of abilities, high molecular weight, higher thermal expansion, thermal stability, a wide softening range. And I told you only the thermoplastics material can be used for this thermoforming. Also, the material should exhibit a reduction in their modulus, the elasticity, their stiffness, and load-bearing capacity. Also, we have seen the thermal diffusivity yesterday. And also we have the property which polymer should have, that is the water absorption capacity should be lower for the thermoforming process. Now, what material? Polystyrene, ABS, PVC, acrylics, polycarbonate, SDP, polypropylene. We have seen. We have seen also the videos on the machines. Actually, the product. This also we have seen yesterday. The control panel board is there. The seat is get clamped now. Now the heating start. The heaters came down with a specific distance. That is the radiation. And now when the temperature reached, then it may automatically going up. After that, we have a mold. There's a deep draw mode, and we have also seen the automatic lowering of the heated plastics, and the plastic will take the shape to the vacuum and supporting air stream. Therefore, thermoforming with vacuum and supporting hot air stream, it will take the actual inside and outside part get covered by this. After that, cooling will start and the article is removed. It's called the deep drawing article. Now, after that, they will finish this, and now, therefore, then material preparation we have seen there are three processes: extrusion, calendering, and casting, by which we can produce the article. We have seen all the MOC required for the material. Then heating also, infrared heaters are used for the heating purpose. Electrically powered infrared heaters also used. Then stretch issue also we have seen yesterday. Now we are here yesterday that the types of the thermoforming process. Now, friend, if you see here, there are 8 types of the thermoforming process. Many of these types we have seen the video also. Straight vacuum forming process, pressure forming process, plug assist forming, free forming, drape forming. See, just now we have seen this just a 1 minute back that we have seen a drape forming, snapback forming, match die forming, and a mechanical forming. We have seen yesterday this technique is the most versatile and widely used. Straight vacuum forming. The plastic is clamped in a frame and heated. The hot sheet become rubbery or pliable or elastic. It is a place over a female mode cavity and the vacuum is now applied. Now, from the other side, the atmospheric pressure forces the hot sheet against the wall. And counter of the mold. It allows to cool the air. The formed part is removed and final finishing and deposition is done. This technique is used when the outside of the part must have a fine details or a close tolerance that we have seen. This process is limited to draw ratio up to 1.5 inch. Draw ratio is the ratio of the draw depth to the part width. See, this is a vacuum forming. This is the mode here, female type mode. The sheet is here. Sheet get heated here, friend. And after heating over, the sheet is placed on the female mode. The vacuum is created here so that the sheet will take the form of this mode here. Okay, it's a very simple process. We have also yesterday seen this video, and You see here is a batch type process here, friend. Very simple. I told you the details. If you want to details from the top, then the first method, straight vacuum process is used. See now this is a HIPS sheet. The mode is wooden mode. Now they are opening the clamping and they are just removing the articles. See, the article is a huge one and having all details. This is also a batch type process, friend. There are two type of process, continuous process as well as batch type process. See the heaters are there, which will heat the sheet. See now they are fixing the sheet now with the help of clamp. See now the sheet is get clamped by the frame and it is going to now heating station. Now the see the how they operating the mode. See now the mode is here. And I told you, if you want to outside details, then you have to use this straight thermoforming process. See now on the mode, there are some ribs are here. You see here 1, 2, 3 ribs. Now see the how it is acting, vacuum thermoforming. See now the details here. All details you are getting here. All details at the top also. Yeah. So a friend, this is one of the a unique process. See now cooling start. And the article is going to remove now after cooling. See now the details they are showing us. Article removed from the mold. See the details are there. And such a, use for the ice bath, see this is a, for medical purpose, we can use such a type of article to preserve our medicine and others. This also we have seen yesterday, thermoforming method. Okay, to see here, we have seen this yesterday, but again you can have a, I told you, this is a how the thickness goes varies. See now here, see now your thickness is very lower as compared to this. We have seen this yesterday, friend. See now the thickness is higher here in this case. We have seen this yesterday. We'll go the pressure forming method. It is similar to straight vacuum forming process. Here also plastic is formed in a female mode. Here instead of applying vacuum, a positive air pressure. See the name indicate pressure on the top of the plastic is used to force the material against the female mode. The sheet is clamped and heated till soften. The softened sheet is transferred to the molding area and seal is to made so that the upper chamber above the plastic is airtight. The sheet is also sealed against the mold as is done with the vacuum forming. Air pressure is applied into the area above the softening plastic and vacuum is created below it. And the air pressure and the vacuum forces the plastic against the mold. See now here. What is happening here? The sheet is heated here. And there is a compress here. You are pressing from the outside here. The article get formed here, friend. What are the advantage of the process? Pressure forming process. Mold cycle is faster. The sheet can be formed at lower temperature because the forming pressure is higher.
Sir, one doubt.
Yeah.
Sir, are we repeating yesterday's lecture, or are we continuing you?
No. I am some part I am repeating here, friend.
Okay.
Some part. Just important part is that applications is a very important and the types, right?
Okay.
Just 1 minute. Let me because it's a very important topic. Once it is
Any important topic? Okay.
There's a plug assist forming also, friend. Because once you understood this, then you can easily say that this is made by the plug assist forming, right? Therefore, a male plug is also used here, friend. Plastic is clamp. The same thing here. Only the plug is adjusted here. See, we have seen this also yesterday. Is a plug here. You are just pressing this by plug first, and then you are applying the vacuum here, and then the sheet will take the form of the mold here, friend. The advantage I told you, deep and more uniform wall thickness is obtained, and this is now preforming. The sheet is expanded with the pressure. We have seen this. Just they are putting pressurizing the air here from the bottom, and there is a bubble form, big bubble form. The size of the bubble is monitored by the electronic eye. Therefore, friend, it is a completely controlled here, a big dome. If you have seen at different places, maybe of polycarbonate, polystyrene, HIP, not HIPS, acrylic plastics, or decorative domes. They are manufactured by this preforming only. What are the advantages? No mode is used. Product have see here, no mode here, no female mode or not a male mode here, friend. See, no mode here. And handling of the sheet only how to clamp, simple and economical, uniform cooling. The product have a very high optical clarity. I told you for polycarbonate and for the acrylic polymer. Disadvantages, complexity of the shape cannot be made. Yes, because it's a dome only without mold, not possible. The control over the shape is difficult. Now, drape forming. The plastic sheet is clamped and heated. Then the drawn over the mold either by pulling it over the mold or by forcing the mold into the sheet. The seal is created. Vacuum is applied beneath the mold and forces the sheet over the male mold by the atmospheric pressure. See, here is a male mold frame. Very important. For the drape forming, we have just seen the video, right? That was the male mold and drape forming. Just we have seen just now, last video. By draping the sheet over the mold, that part of the sheet which is touching the mold remains close to the original thickness of the sheet. Side walls are formed from the material draft between the top edge of the mold and the bottom sheet area of the base. See now, here is a video. It maybe you have seen yesterday, but again, just check up, Uh, yes. See now here, a draft farming method. First, see male mode is there, friend. Both are male mode here. See, both are male mode here. All are a draft farming process, friend. See, these are the draft farming process. Initially, you have to pass the ear there, hot ear, and you have to take suck on the a male mode. Therefore, here you are using the male mode, friend. Very simple process to manufacture the article. See now, this is the male mode. Now here's a figures I am showing you. Just we have seen the video also. You are hitting and you are just forming the article here. Advantage, greater depth of the draw can be achieved without C. We have seen this. A thinning compared to the forming in the female mode. Female mode में ज़्यादा thinning होता है. You are getting a more thinning in female mode, but in male mode, it is not. And therefore, ultimately thickness is much better as compared to the female mode, which is we have seen the vacuum forming. Now here, snapback forming. It is the modified form of the draft forming. The sheet is heated to the sack point. Then it is drawn slightly into the vacuum box below the part. This pre-stretching creates thinning effect of the center of the part. It is generally to 1/2 to 2/3 of the total draw. The second step, finally the second step is then agitated to give more draw. The male mode is pressed against the material to draw it further. During this stage, the thickness of the material is constant at the center and thinning occurs near the edge. Finally, the part is formed by the applying vacuum through the sea. You have to apply the vacuum and you have to use the male mode here, friend. And you will get the snapback. The part snapback against the outside of the mode. The part cools and the remove. See, this is the method, friend. You have to heat first male mode, the sheet, and vacuum chamber below the frame. See, this is a vacuum chamber. Here is a sheet. Here is at the top. There is a male mode. See now here, the vacuum chamber up. It is going up now. The heater applied. Here the vacuum is applied here, friend. See now, the sheet will take form here. See now, the sheet is bent now here, friend. Okay. And it will just, we have applied here the vacuum here, friend. After that, see now, the male mode, it is pushing that sheet as into the female mode. And afterward, see now here, the air pressure vacuum chamber retract the fans. See now your fans are from the outside to cool the sheet. And see now where the article is now with the a male mode here. It is a, see now here, where is the article? Article is now here, get reached with the, see now, article is with now male mode, not here, see now. And in such a way, cycle, this is called a snapback, friend. Snapback means it is the article is going with the male mode, not with female mode. Okay. And now this is a very good process, friend.
From first, can you explain, sir? I could
What are the
not.
advantage? Uniform wall
Hello?
thickness, complex shape
Hello?
can be
Sir,
formed.
can you-
Yes.
Hello,
Longer
can you
cycle
hear me,
time,
sir?
but there's a disadvantages.
Hello,
Now,
can you
many
hear me,
cases
sir?
and luggage sheets are manufactured by this
Yes, we can
process.
hear you. Yeah, sir.
Comfort housing,
Someone is asking questions,
acrylic
sir.
cast sheets also manufactured by this process.
Sir,
Hello?
can you hear me,
Match
sir?
die molding. Match die molding here, friend.
Sir, can you hold, please? Hello.
Hello, sir. Can you hear us?
Yeah, we can hear you. Yeah.
Hello, hello. Am I audible?
Sir,
Audible?
can you hear us, sir?
Hello.
Hello, sir.
Ah.
I think you are not able to hear us, sir.
Yes. Now, am I audible now to you?
Yeah,
Audible, audible.
Yeah,
Can
yeah,
you
yeah.
hear us, sir?
Yeah.
Can you
See,
go to the previous slide, sir?
yeah. Okay. See now, friend. This is
No,
a, we are talking about the snapback. It is a modified from the trap farming. Same method. Only we have to hit at the sack point, and you have to draw the vacuum, right, from the box. And here is a mail mode you have to use. Mail mode. Second thing, you have to this mail mode press against the material to draw it further. And during this stage, the thickness of the material is a constant at the center and thinning occur near the edge. Right. We have seen this video, friend, snapback ka last, that the only the that last video, thinning at the side or thinning at the base. This is the same method here, friend. We are using here a mail mode, right? And the snapback. Snapback means what? The article is going towards the male mode, not with the female mode. The part cools against the mode to take its final shape. Now see here. Here is the sheet is heated, male mode. Now see here the cavity is there. Here the to apply the vacuum, friend. Now the sheet is completely heated here.
Here, where is the sheet, sir?
Sheet is this. This is a sheet here. This black one. This is a black one. Sheet is here, and here is only heaters. Both heaters are there. A sheet is here, and here is a male mode, and the vacuum is applied here. The sheet will just curve here. Okay. Heater
Which
is
one
also
is here at the third slide? A sheet is clamped at the bottom, but the second slide it is somewhat lifted. So bottom will go up and it will close that, sir.
no. See, this is a figure. Here, just they have seen here the heaters are there. Male mode is there. Okay, and the down bottom there is a the vacuum system is there. Now, see now here, the sheet is just introduced here. Sheet is pass here, friend. Okay, here only. Sheet is not here. Sheet is here. See, now this is the black line. The sheet is there between the two heaters. Then after that, see the vacuum is applied. After that, the
So
heater,
the bottom, there is a bottom cylinder which is going up, or the total unit is coming down.
yes, correct.
Here, sheet is getting engaged with the bottom.
Correct. Yes.
Second,
Now
there is a
yes.
difference.
Now see, this is the going up now. This is the
Okay.
going up. Therefore, sheet is now taking the form. Vacuum is applied here, and see now here, the male mode is coming down here, friend. Okay, for me, complete vacuum release for. See, the vacuum should not be released here, friend, until the male mode come down. Okay. Now see here, this male mode go up with this article. It is get forming here. Article completely form here, and now the male mode is going up with the sheet, and this is called as a snapback with the article. This is called as a snapback process. The article goes with the male mode.
Third to fourth slide, after the vacuum is applied, top one is coming and holding it. But how the material is formed, sir? Because third slide it is a round shape. Fourth slide it is a tray shape.
Yeah. See, here is a no sheet. Here is a sheet is you introduce, right? Right. Here is the heaters are there. You are just heating that sheet up to the melting that softening point. Okay. Now this system will come up now. Vacuum system will come up now. That time again you have to apply here some vacuum here. So slowly you have to apply the vacuum, not 100%. Okay. Now see now here 100% vacuum they have applied here, and see now here the sheet is taking the form of this male mode here. Okay. Now after that, see the sheet is now here the cooling take place. See here you are passing the air from the both side for the cooling purpose, and see after that, after cooling, the article fall down. See now article now here. Okay, this is the snapback process, friend. See the advantages: uniform wall thickness, complex shape can be formed, and the longer cycle time. Because it is the, see now here, 1, 2, 3, 4, 5. There are 5 steps. Okay, and so that it will take a longer time. Are many see now what are the application here? Many cases or luggage seats, computer housings, acrylic cast sheet also get molded by this method. Then match die molding. This is a match die molding, friend. This method resembles to that of the compression molding. It is just like a compression molding. The plastic sheet is heated to the sag point. That is a, sag means a pliable point. It is a trapped and formed between the male and female dies. See here, both male and female die are used.
Sir, in the drawing, can you show sag pointer?
Which one?
In sag point, SAG sag pointer. Can you show in the drawing?
Yes. No, wait, I have the diagram. See here, it is a trapped and formed between the male and female dies. The clearance between the male and female dies decide the wall thickness. See now here, I will show the, see, this is a male mold, this is a female mold, and this is a sheet here. You have to heat the sheet. Top say the ram is there, and it will just take the shape of this. Just you have to take this down ram, and see now it will take the get the shape of the inside of this between the portion of the male and female mold. Very simple process, friend. It is just like compression molding process. Nothing is there. Very simple. Therefore, it is called as a match die molding frame. If you see here, vents are provided here, friend, to pass the air, and here is a atmospheric pressure will take place. See now, here is a no vacuum is applied here. No vacuum is applied. This is the atmospheric pressure. Okay. Now, what are the advantages? Very good production of the mold details. See here, reproduction of the mold details. All details you will get. Very good dimensional accuracy. Lettering and the granted structure can be easily formed. And disadvantages are internal cooling of the mold is desirable. Yes. Now here, friend, this is a match die. 1 minute. Mechanical forming, friend, here. Mechanical means suppose it is a cold molding. इसको हम लोग क्या बोलते हैं? Cold molding भी बोलते हैं, right? Now the sheet is clamped and heated. Mechanical pressing is done against the inside a forming tool such as a bracket to give the desired shape. See, I will show you the mechanical diagram. Oh, diagram is not there, side. It is same like a, that this one. It is same like this. Okay. What are the other things? The sheet is clamped and heated. Mechanical pressing is done against the inside of a forming tool, such as a bracket, to give the desired shape. The plastic sheet cut to appropriate shape and size, and then heated to the sag point. The pressing can be done by the roller, a block, or any other instrument to apply the relatively uniform pressure on the plastic sheet when it is still hot to create the desired shape. The formed plastic sheet is cooled in that place, at the same place. In the mechanical, okay, this is just like, that in a mechanical industry also, we are just molding that plastic galvanized sheet, but here you have to heat the plastic sheet first. Now, inline thermoforming process. Now, till now, we have seen all a batch type process, right? Batch type means take the sheet, put in the clamp, heat the sheet, and take the mold up or down, or maybe the plug take up or down. We have seen such a type of the systems till now. Now, there are also inline thermoforming process. Inline thermoforming process means what, friend? Here, the sheet is forming many times direct extruder, direct granule. The sheet is forming in the same plant. At the same time, it is going ahead. Then thermoforming take place. Same, at the same, there is the printing, everything will be online, right? Inline process. The friend, inline thermoforming mainly meant for the continuous sheet forming and production. Continuous, it is not a batch type. It is a completely automation are there. If the forming process can be accomplished during the time it takes to extrude the sheet, and if long production runs are involved, inline extruder thermoformer would be considered. Yes. Now, what are the advantages of this? Because it is the inline process, the advantage is that the material is already available in a very uniform temperature, and it might not have to be preheated, because you have a reel of the sheet or film and it is not preheated. Any cutouts, margins, and trim materials can continually be regrinded and re-extruded, thus solving the problem of eliminating the scrap material. Yes, while forming the sheet, you know that web, there are a side scrap is gathered, and that side scrap you have to again cut and again you have to reuse for that. The virgin regrind ratio remains constant for the each product. The disturbances found when external regrind are reprocess are avoided. Yes, if you use the virgin material, then nothing will happen. But if you use regrind material or maybe excess of regrind material, then there will be some disturbances in the troubleshooting while taking the shot or maybe doing the thermoforming. Now, improve the extruder technology and the increase the use of gear pumps, which eliminate the extrusion surging help too. Yes. See, if there is a constant flow in the extruder barrel, then we are using the gear pumps. Secondly, if the material is have a very high viscosity, such a time you have to use the gear pumps there to push the material constantly. Now, friend, what are disadvantages of this process? The problem arising at any point may require the shutdown of the whole production line. Yes, because you are using the granule extruder, you are manufacturing the sheet, and that sheet is going to the thermoforming process. Afterward, there is again many inline equipments are arranged serially, and suppose anything can happen with any point, then definitely you have to shut down the whole plant. That means manufacturing sheet to the thermoforming, and that no printing of the sheet is possible here. So, friend, that is a continuous forming method. I will show you the video also of this after this. But also, we have seen that many potato chips, you know that a pouch you are getting from the market, that is nothing but the twin sheet forming method, friend. They are manufacturing the twin sheet thermoforming. All potato chips, all groundnuts, and many things, right? You have seen any shop, you know that if you visit, even school student, they are taking that pouch. Okay, potato chips pouch, groundnuts pouch. There are even banana. You know that slice pouch also available in the market. Many pouch, and that all pouches are made by this twin sheet thermoforming process. Twin sheet. Now it is a viable process frame for many years, and how this is done here, two sheets are kept separate while heating. See, here there are two sheets. Okay. If you want to make a pouch, two sheets you have to keep this separate while heating, then brought together in a double female mode. Because you want to make a pouch, therefore there are a double female mode arrangement will be there. Upper and down. A blow pipe is provided between the sheet and the, yes. Now see the blow pipe. What is a blow pipe? Why it is used blow pipe? To pass the oxygen. Okay. See, you cannot preserve that at the atmospheric, that oxygen here. We have to keep a separate cylinder of oxygen, or maybe, that nitrogen, not oxygen, nitrogen. Okay, a blowpipe is provided between the sheet, and once the sheet are clamped together, their pressure inflates them against their respective molds. Twin sheet forming produce a relatively flat hollow part that can be filled with the PUR foams for additional stiffness. If you want the additional stiffness, yes, you can pass here a foam, polyurethane foam. For large heavy gauge part, the technique compete with the blow molding in a roll-fed thermoforming. Roll-fed means there is a roll of a sheet. Thermoforming, twin sheet forming is used. Now in packaging, I told you just now, in packaging, pharmaceutical packaging, maybe food packaging, the packages that provide oxygen barrier to the product are desired. See, even you potato chips you are keeping in the pouch, they are free from the oxygen. There should not be oxygen frame. Now, how can you put that? There should be a barrier, oxygen barrier property. The most effective barrier material developed for these are the laminates. They are essentially incompatible plastics. Ethylene vinyl alcohol, polypropylene, polyamide, polyethylene terephthalate, and saran, PVDC. These are the generally material which are the incompatible to each other, and they are providing a good barrier property for the oxygen. Now, the web and trim scrap from co-extruder laminates of some of these material cannot be used because they are mixed together. As a result, variation on the twin sheet thermoforming process has been developed. See now, friend, why it is developed? Because there is a contamination of the material. To avoid that, therefore, we are keeping that two layer of the plastic, right? A single layer at the bottom and again single layer at the top. And the sheet are fed from the individual rolls through sandwich heaters and brought together at the forming station. Once the multi-layer formed product has been trimmed, see now, once that multi-layer sheet and the pouch will be formed and the side get trimmed, the individual layer are stripped from the resulting wave. Yes, you can easily remove PP film, polyamide film, PVDC film, right, from each other afterwards. Each material scrap is therefore clean and can be recycled to produce a new sheet. The diverse layer of the material in the form product are only contact adhere and so can be delaminated through misuse. Correct. Therefore, the polypropylene will go with the polypropylene, PET will go with the PET, PVC will go with the PVC, PVDC will go with the PVDC. There is no adulteration of the material frame, and such a method is very good, accepted by the industry. Now see here, twin sheet roll fed. See here, this is a mold here, female type of mold. It is a preheated one, right? And a separate roll, a thin gauge. Thin gauge sheet prior to forming. It is a heated one frame and vacuum forming into the female mold. See here, vacuum forming take place, right? And then trimming, separating of the trim. See now here, how the things are happening here. See, first you have to heat this, then you have to apply the vacuum here, then it's a vacuum forming process here frame, and again you have to cool this. Okay, cool this here. See now, it is very simple, I think, friend. You have to apply the vacuum and hold down the place for the trimming in the knife. You have to trim this one from this side, and you will get a complete pouch of that. See now here also, you can see here a pressure reverse drop forming, plug assist forming frame. See here, this is again a different type pressure reverse draw with a plug assist. First, see here a pre-heated sheet prior to forming. This is the pre-heated sheet prior to forming here. The sheet is there, the plug is there, friend, and see here there are different things they have shown here by the arrow also. See here, the pressure box is also there, friend. Okay, this is the pressure box. Okay, and through this we are applying the pressure here afterwards. Vacuum is from the downward portion, and this is the very simple method. Sheet vacuum formed into the female mode, right? See now this is the female mode here. This is a box here. This is here a plug. Okay, plugs. See now the plug move into the sheet while here pressure. See now first you have to pass here a compress here so that the sheet will get a dome-like structure here. See, first sheet you have to heat sheet. After that, you have to close this bag from the top. Then afterward, again you have to pass compressor here, compressor here, till that balloon is touched to this plug, and it will go to that. See, up to the plug will go up now. Okay. Now see afterwards what is happening here. See the plug just via the ramp, it will push this a balloon up to the this level, middle level, and then after that, see from the down, this air pressure is applied again. Here it's a continuous air pressure, and after that you have to apply the vacuum here, very fast vacuum. Then it will take the shape of this. Okay, the female mode. This is called as a pressure reverse draw with a plug assist. Here we are using the pressure. See now here pressure, here we are using the pressure, and lastly you have to apply the vacuum here to take the article. See now in this case, you have seen here, this is a twin sheet. Now see here, vacuum reverse. This is the pressure reverse and this is a vacuum reverse. See now again the same sheet will be here, but see the plug here. No here box, here box here. Now here you have to apply the pressure from the down. It will take the dome, big dome will be formed here till it will touch to this plug here. After that, you have to take the plug down here and you have to apply the same pressure will be applied here, friend. The ramp will come down here. The plug is get inserted. It will just push the sheet downward direction. Now after that, at last, you have to apply the vacuum. Just like the pressure reverse draw with a plug assist forming. Same thing. Only you have to apply here the vacuum. Maximum vacuum you have to apply here. And here, see the atmospheric air pressure will play here. Atmospheric air pressure. See now here in this case, you have to applying the pressure from
the boat will have different shape, no, sir?
But here you are applying the air pressure here. Here, you are not applying the air pressure. It is atmospheric pressure here, friend. This is the only difference between the vacuum reverse draw with the plug assist and the pressure reverse draw with the plug assist. These are also methods nowadays they are using in the market. Now, sheet is a frequently persistent trend with a mechanically driven plug assist that we have seen. The sheet is pressing the plug into it and drawn into the female mode. Yes, we have seen this. Vacuum is applied to pull the sheet against the mode. Yes, if the sheet is forced against the female mode, surface with the air pressure. Yes, we have seen this. Now, below forming and the plug assist forming have been combined in several ways. Once a bubble has been blown, the plug penetrates into the stress into the female mode cavity. At this point, air pressure can be applied through the plug. Yes, force sheet is against the female mode. This is called as a reverse draw with the plug. We have seen this spread just now in the diagram. Now You can say this is a continuous thermoforming process, continuous, not batch. Only the reel you have to put at the backside and you have to start this. It's a very simple process, friend. Here, you are not, see now here, it's a continuous thermoforming. See, when the mode open, there is a air pressure and the blower will push the glasses, very simple process. See, very simple machine, friend. Nothing is there. Only the heater is backside and the reel is there. And the mode is, see how within the one shot, you are getting the 16 or maybe 20 glasses.
Sir, it is done in which processor? Vacuum or plug type or which one, sir?
Yes, yes.
Whatever you are shown now, it is of which process? You are explaining some earlier process, no? Pressure and vacuum release, vacuum pressure release. Like that.
Yeah.
This is of which process?
That is no. We have seen that is that batch type process. Batch type. That is not a continuous process. You have to cut the sheet. You have to put the sheet there on that. You have to clamp the sheet by your own hand, and you have to take that is all manual operation. But now see here. Here you are just loading the sheet of roll, and but after that the heating is going on, and there is a simultaneously there is a thermoforming will take place. You are getting a 20 glasses within a fraction of second, and after that the glasses are removed by a blower. There's a blower when the mode open. Okay, very simple process. But that is the best type process I have shown all the types, right? This is the second, video frame. You can see here. They are all dimensions they have shown here. Output also they have shown here. See which are the, the product you are getting here. That also shown here. It's a huge plant, big plant frame. These are the hopper dryer here. Hoppers also there. This is automatic plant frame. These are the extruder. See the material here. See now, this is the extruder here. See the continuous sheet is forming their frame. You are producing the continuous sheet. Now the sheet is going to the thermoforming machine, right? From granule to direct articles. See now, here is the extruder. Sheet is going through forward direction. See now how the glasses are manufactured here. Does not need to again reheat the material because the sheet is just, you have seen here, the sheet is just forming here, friend. The simultaneous process is going on now. Here is a no sheet is here. Here the sheet is just manufactured and the same sheet is going ahead in the thermoforming, a continuous process, friend, from granule to the article. This is a continuous thermoforming machine. You see all these, you know, for nursery, we are using this type of a bucket.
Sir, the two color is it is a painted one, huh? Inner is black color and outer is some, or it's a two different sheet.
Hello.
Hello.
Yes.
In that video, initially there was a sheet going in, which is top side brown color and bottom side black color. Whether
Yeah.
it is two different material or it is a two sheet done in calendaring, or what? How that process?
No.
Has
There is a lamination. There is a lamination take place between the two sheets. Now the two sheets are manufactured there simultaneously, right? There is a two extruder actually, one extruder for the red and the other is from the black, right? They get laminated, and after that, that is going ahead. आगे आगे जा रहा है वो laminate, and you have seen there is a brown sheet at the top and dark sheet from the from the bottom side, and you have seen there two type of granules, right? And that they are there is a co-extrusion, and you are getting a co-sheet there. Sheet you are getting the the laminate sheet, and after that they are going in thermoforming machine. There is a no separate heating take place here, friend, because already the sheet is heated one, right? The sheet is simultaneously from the granule they are manufacturing the sheet, and from the sheet they are thermoforming there, right? I have seen such a plant direct, from the granule direct sheet is formed, from the sheet direct glasses or packet is formed, pouch are formed, or maybe the small box are formed, and from the small box they are adding there some material also, material, right? Food material, and then there is a packaging take place simultaneously, and then afterward there is again printing and all these things happening. Such a plant is also there. Therefore, manufacturing the pouch, then then filling with the material, and then sealing also there, and then cutting afterward, and then this.
Sir, are you showing any video? Because that screen is showing blank.
No, this is no. I was showing you video. The
And
one day.
one more request, sir. Apart from that,
Yeah, yeah.
like calendaring process and many other process, is there any industrial visit like 7 days? Because while joining, they told that there will be a 7 days visit, kind of depending upon their location. Let's suppose those who are from Bangalore, they can visit Bangalore location. Those who are Pune, they can visit Pune location. Or is there any plan of industrial visit also there? Because what you are explaining video, if we see physically, na, that will be more question and more practical kind of. Hello, any update on that? Hello.
Hello.
Yeah, I'm asking. I asked a question.
Uh-huh.
Shall I repeat my question again or?
No, repeat. The sound is very less. Abhi bolo.
Okay. So I'm telling that while at the time of joining, they told there will be a 7 days industrial visit depending upon location. Let's for those who are from Pune, they can join Pune. Those who are from Bangalore, respective city, they can join. There will be a kind of, because right now we are referring video. If we visit physically any particular industry, then there will be more practical questions. Or so any update on that?
Yes, you know that after this course, there is a always the possibility that the management will give you some visit also. Those are here in Bombay base or maybe at the Bangalore base. They have their attachment of the blow industry, thermoforming industry, injection molding industry, and extrusion plants. Right. The in the vicinity, maybe at Bangalore, Chennai, Hyderabad, Delhi, they have their own IPI chapter, Indian Plastic Institute chapters, and they are arranging their visits there.
Okay,
If
if any
you,
particular.
but you have to ask the concerned person for that, so that they will arrange afterwards. You know that maybe this after these lectures, they will arrange direct demonstration of the plant, right?
You're right, because all these
Yeah,
plastic
but
processing.
this is again, but you have to start the process. You have to request them. We have to see the plant like that.
And maybe I will send a
Here,
mail. I
just I
will
am
ask.
showing you the online video, right? But you are not
Yeah,
getting the details here, right? But when you
no,
and the video
we
also,
we got it, but based on our experience, we got it. But it is always good meeting physically,
yeah,
because there is
I'm
a lot of
trying to show
process.
the various type.
I'm not completed yet. Sorry,
Yeah, I
sorry
am
to stop
trying to
you.
show you the various type of that videos so that you will get the idea, right?
Because
What
calendaring
is
process, I never seen that calendaring process. So maybe I will contact you when I will
yeah,
be in
yeah.
Bombay. You mentioned that you are a student.
Yes, there is a Caprians industry. Yes, the Caprians industry, you can go there, you can visit Caprians. That is at Nasik plant, even at
maybe I will connect you personally.
Bhor industry also. At
Okay, sir.
Bhor, yeah, definitely. Yes,
I will
sure.
request other student also to send a mail. Maybe they can share
Yes.
the agenda in advance, so that we can plan accordingly tickets
Correct,
kind of.
definitely we will help you. Don't worry. For the visits, definitely this department and will personally help you. Don't worry. See now here how the the small pet uh, pouches are made. You know that bowls are made.
Sir, if you can explain whether it is a needle type or vacuum type, pressure type, like that, whatever we have learned so far, that we can recollect and see, sir. Hello?
This is the wave frame, and this wave is again a regrind, and again it is used in the granule, maybe 20% or maybe 10% as per the permissible. Okay. This is a continuous thermoforming process, friend.
Sir, which of the, whatever you have taught us in that, this belongs to which particular process?
I am not, that. Yes. Please, pardon, please.
So we have learned some pressure vacuum like that we have learned so far, and needle type, some punch like that, something is coming from the top, and for some, in some case in from bottom it has come. Which particular process is this? If you can tell, we can align to that theory whatever we have learned.
Thermoforming process. Hello.
Yeah,
You
yes,
are
yes.
you are talking to about this thermoforming process.
Yeah. We have you have given some theory class, and this video belongs to which particular theory class?
Yeah.
You can relate it and see.
But thermoforming, if you see, there are, in any this MIDC, you will get, there are even at, you are staying where? Hello?
Yes, sir.
You are staying where?
I am in Mysore.
Mysore, yeah. See, in Bangalore also, there are many thermoformer. They are using these thermoforming machines, right? And the Bangalore also, maybe the IPI having a chapter there, IPI chapter, and you can contact them also. Uh, they definitely help you to arrange the visit, this thermoforming plant. Okay.
That's what those they can we can send a mail. All student can send a mail. They can share the agenda.
Yes, that is also done.
Even that those who can come from Pune also, they are welcome to Bangalore also. So each city wise they
Yes.
can arrange accordingly. I think.
Definitely they will arrange for you. They always help. This department is always help for the student to see the demonstration of the plant. And nobody will say the no to us. Right.
Sir, my query is, you have given a theory class and you are showing a video. This belongs to which particular theory? Which particular farming process you are showing? If you can tell that, we can relate that. That is what I'm telling.
Correct. You are right. Correct. Yes. 100%. See now, this is a another plant, right? We have seen this. Now co-extrusion and laminates. Co-extruder and laminates sheets. Laminate sheet have a gain favor for thermoforming process. See, I just shown you co-extrusion, right? Co means there are two extrusion. By the term co-extrusion is meant for the formation of a sheet produced by the simultaneously employing the two or more extruder. The term laminate should be always be employed when either two or more previously extruded or the calendar sheet combined or bonded. Usually, laminates are obtained by pressing several layers between chrome-plated steel sheets. Now, co-extruded product and laminates are used when parts are required which have a different color on the inner and outer surface. Just we have seen, and plain coat of paint is not adequate. Okay. Afterward, parts are subjected to ultraviolet radiation on the outside, but lower cost material suffices to provide the mechanical strength. See, these are the friend, low cost grind or scrap material are available, but part with a high quality appearance are demanded. These are the major thing, friend. Coaxial and product laminators are used when we have to use this. Now, difference between thermoforming and injection molding process. See here, thermoforming require a more expensive sheet as a raw material, raw stock. But here we are using the granules, right? And therefore, the cheapest form of the raw material. Here is the, if you see, you have to first form the sheet from the granule, and then you are using here sheet for thermoforming. Here granules. Thermoforming dyes are made up of wood, plaster of Paris, aluminum, and its cost is subsequently low. That we have seen. But here, the mold cost is very high because all CNC machine, you have to do many things here. The third one.
Last video what you show is injection molding along with thermoforming or extruder along with thermoforming, sir.
Extruder along with thermoforming.
Okay. Okay.
Yeah. Here I am giving a difference between the thermoforming and injection molding process, friend. Now, if here I told you sheet require, here granule require. Here the mold cost is low, here mold cost is very high. Here the number of particles to be produced is less than the choice would be thermoforming. Here injection molding is suitable for large production. Large production. Here is also a suitable type of article you can manufacture. Now, here operation is a very quick, very large article you can manufacture. Here in this case, operation take more time. Second type take more time here, friend. Thermoforming sheet can be printed or decorated before forming. Here, injection molding decoration is not possible before processing. Yes, it is not possible. Here, sheet you can have a design also, right? And you can produce the article. Holes and undercuts cannot be here possible. Here, holes and undercuts possible. Now, thermoforming is adapted to the production of a very large part. Here, injection molding product not for large part, for all type of small size, a different type of smaller size parts. This is the basic difference between.
It will be a trailer roof.
Which one?
You mentioned that thermoforming is adaptable to the production of very large parts such as trailer roof.
Yes. This is a frame. See, we have seen very large part you can manufacture a very big dome. We can manufacture by thermoforming or roof. Very big roof we can manufacture by. Yes,
I thought it's a trailer joint. Okay, I got it. It's a big part, kind of. Okay.
You know that if you see the dome, the houses made in the that earthquake places where they are making the house of the to save their life, friend, and that house is the all the things they are get the thermoformed sheets, right? I will show you the video also if it is with me now, right? Thermoforming part require a final trimming. Here, not require. Pressure required is lower here. Pressure required is higher here. Scrap production is very high, very low in injection molding. Lower machine's original cost, where the machine cost is very high. And we have seen, see now these are the frame packaging and related items, blister pack, bubble packs, cosmetic cases. Then all these we have seen day to day. We are using this packaging product here. If you see the any mall or any places, you have seen all these thermoformer product there only, friend. Even the tablet which you are buying from the medical, that is also thermoforming machine. Every industry, medical, that pharmaceutical industry having the thermoforming machine. Food industry, they are having thermoforming machine. Now, see the vehicular, automotive door inner liners, window seats, motorcycle. See you are now asking me the large particle, large articles. See, these are all large articles here, friend. Right? Window blisters. These all are large articles. Now here industrial panels, pallets, part trays and transport trays, equipment cases, building product, shutters, windows, skylights, translucent domes, exterior lighting, then storage modulars, then bath tubes. These are all manufactured by the thermoforming. Interior signs, luggage trays, boat hulls. See, whatever you are using the boat, right? That all you are seeing the all beaches nowadays. The boats are made up from the plastic only, and of the thermoforming process. Advertising signs, lighted indoor signs. Now, which are the fault here, friend? The blisters, right? If it is why the blister form heating too rapidly, then these are the remedies for that. Excess moisture is also why the excess moisture, and because the plastic absorbs the moisture from the atmosphere, and therefore this will be the blister marks. White lines. What is a blister? White lines. And then you have to pre-dry the sheet material, preheat the sheet, heat from the both the sides.
Sir, you are you are covering that that thermoforming defects, right?
Huh.
So is any image of the part is there so that we can understand? Because injection
Uh,
molding part
no,
defect
I
we know.
no. I don't have that image. Like injection body, I have shown you, but here,
Sorry,
blister means white lines are there on the article that articles. That is called the blister.
maybe next class you
Such a
can
slide I
maybe
don't
next
have.
class you can show
No,
some video or PPTs kind of.
no. Such a
Or
slide I don't have. Blisters, this with me. No, it is not with me because thermoform that. But I am telling you that is a blister means white lines are there, and that line due to the only the preheating the drawback of this, right? If you're not preheating the material, the lines will be always absorbed on the article, and even uneven heating. This also, suppose you are not heating properly in the thermoforming, that also create the blistering problems. Incomplete forming, sheet too cold, and insufficient vacuum. These are the two main causes for the incomplete forming. If not proper heating, then you have to heat the sheet, raise the temperature of heaters, use more heaters, change to more efficient heater design, and insufficient vacuum. If it is not, you are not applying the 100% vacuum there, then sheet is not get oriented. Can we take a break, friend? 2 minute break. Hello, hello. Can we take a 2 minute break here?
we can take.
Sir, okay, sir.
Am I audible to you? Hello? 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 Am I audible to you?
Yes, sir, you are audible, sir.
Yeah, yeah. See, friend, I am trying to cover the. See, we have got this only one lecture for this thermoforming, but I am trying to give you a maximum, in and out of the thermoforming process and the machinery, right? Even the mode also, the process also, the machine also, right? Therefore, uh, there may be, that in the troubleshooting, I have only the, that there is no a color picture with me. Okay. But this, I'm trying to give the best to you in a thermoforming, right? Whatever the things I have till now, I'm trying to, trying to give you, so that you will get a good exposure of that. Now, friend, here uh, vacuum not applied rapidly. Therefore, this also get a short. Why the article is a short? That because of the not proper vacuum, not proper pressure, right? Therefore, you have to see the pressure, temperature, and the vacuum. These are the main things for this. And see the temperature. Okay, not proper vacuum, not proper pressure, and these are the main things behind the this short of the article. Then scorched sheet. The sheet is not improper. The sheet surface too hot, right? And then this is the scorching take place, friend. Therefore, you have to shorten the heat cycle, use slower soaking heat, consider convection heating, right? Color intensity changes. If you see the color, you are getting a dark red color, but after processing, you are getting the faint red color. Why this happen? Because of the insufficient heating, excessive heating. See that therefore we have to use a the length heating cycle. You have to consider raise heater temperature, change to more efficient heaters, reduce heater temperature. Okay. Therefore, you have to use the optimum temperature here for the color. Generally, the color get faint due to the high heat frame. More too cold. That is also one reason for the for this color. Then sheet cools before fully formed. Right. The sheet cool get cool because of the that by the cooling action cooling, very fast cooling. That may be the reason for that. Poor mold design. That is also one reason. Whitening. See, generally what happens while you thermoforming, when you stretching the material, that time the whitening some comes out from lines, whiting lines, not silver lines, whiting lines. Why this happen? Stretching below forming temperature. You are stretching that material, maybe by the plug or maybe that by any pin. Then therefore you are stretching below forming temperature. The temperature is not softened temperature there. Therefore, increase the temperature, increase the forming speed, sheet, dry color. Due to that, also the whiting will observe. The surface dismisses. See, it may be poor vacuum, mold too hot, mold too cold, rough mold surface, scratch the sheet. These are the main reason. But you have to just solve this by using a proper technique. Then shiny streaks. Many times some shine type of streaks are observed on the article. It's a local overheating. Due to that, it is a possible. Then how can you overcome? Check heater temperature, pattern heat,
In
air cool locally, reduce heating cycle.
hello, so can you hear me?
Yes.
Shiny sticks will come only in black color parts, no?
No. At every part, shiny streaks that come on any color frame, not only the black part. Okay. Yes.
Okay.
Wrap warped parts. See, we have seen the when you after molding, some warpage will be there in the article. And why this warpage? Because of uneven cooling, poor material distribution in a part wall, poor mold design, mold temperature too low, and therefore you have to use a proper mold temperature. Your design also, mold design also, you have to see the vacuum hole are block or are they okay. Even stretching, that plug is good or not. That plug at the right time, it should go there. Poor temperature, maybe that the temperature at corner is very high and at different place. Generally, the uneven temperature, this also indicate the warpage. Shrink part. See now, here is also a shrink mark observed in thermoforming. Inadequate vacuum, surface too smooth, but this shrinkage is very low in case of the thermoforming process frame. But they have given here because of the very thin article, maybe there may be a shrink mark, and these are the causes and these are the remedies for that. Parts stick in a mold. So this is a very important frame. Why? Because the temperature is very high. Therefore, inadequate draft. Whatever the design the mold, that there should be a proper draft. The mold undercuts. Due to that also, the part will stuck to the mold only. Sheet tear while forming. See now, this is a many times happen because of the thin sheet, not proper mixing. Sheet is not complete. There are mold design problems. Sheet may be very hot or very cold sheet that also affect the steering property. Then sticking in a one spot, maybe that way the sheet will turn out, or it will get the breaking the sheet. Wooden mold that also affect the sheet. Rough mold surface that also tearing of the sheet take place. Then corner cracking in a service. This is due to the corner. You have to observe only the stress concentration plane. Therefore, here is very important. Stress concentration, it is always at the corner. And therefore, you have to increase the radii, corner too cold during the forming, increase the mold temperature, increase sheet temperature, increase forming rate. These are the main causes behind this stress concentration at the corner. Now, excessive sag. Excessive sag means what happened? The diameter goes on decreasing, right? The thickness goes on decreasing. Thickness goes on decreasing. This is means the sag. Sagging means, therefore, sheet too hot, mate index too high. On
So
sheet,
that point you told you will be showing sag point. You told you have a something video or something to show sag point.
yeah. Sag point means is the pliable temperature, softening point. Softening point.
Okay.
Yeah. Sag is nothing but the softening point. But many times what happen? Excessive sag. That means the sheet jitna chahiye. Suppose we want sheet at a specific level after heating, it should get a pliable, but it is get excessive. The sheet is coming down very fast. Why? Because of the high molecular weight of the polymer, maybe excessive temperature. Due to that, the sagging will be very high, and therefore that thickness goes on decreasing of the article. Very thin corners that also affect therefore here incorrect forming technique, sheet too thin, and therefore that also the corner are very thin, and sheet temperature variation. Due to that also the thin corner will be take place. Variation in a mold temperature that also indicate the thin corner. Incorrect material that also contribute to the thin corner frame. See, this is the one video. This is you can see this, right? So that you will get more exposure about this process. If the pulling rolls are there, it will pull the sheet continuously. It's a heating here, O1 heating is there. See, these are the again some videos I have, but now time is very less friend for us. This is a pet. This is a pet. Bowls. It's also a continuous type of process. See, these bowls are there. First forming this is a forming sheet here. See, the mold is here. These heaters. Heaters are here. See now, this is a sheet. See the roll of sheet. Is the heaters. This is the forming. See now here mold is there. Here is a cutting take place. This is also one video you can see here. See, dome type of, see now here. Only the air pressure will first act. The see now heating is going on. It is a batch type process. See now the pliable. Now see now the air pressure is there. Too much air pressure. And now see the mold come afterwards. See dome type of things you can manufacture here, friend. Dome type of things. Now you have seen here how the dome is created here by, see the very thick sheet. It may be 4 to 5 mm. See, friend, we are, I'm just sharing the other forming now. Our thermoforming is finished. If you have any doubt, you can ask me now here, right? Then we will start now the foaming process. How the foams are manufactured, various type of foams, right? How they are manufactured. If you want to, you can see this video, very small video is there.
Is this a PC material, sir?
Hello, yes.
Is this
Hi.
a
PC. Yes. PC material. Correct. By CNC machine, they are manufacturing the mold, right? See, they are now putting the vent to to get the vacuum from that. See, 8 mm thickness, 8 mm thickness sheet, polycarbonate. These are the vents here, vents are there. See for cooling, it requires, 3 minutes to cool this article. They are doing the stacking now. Again, recycle friend. They are cutting now. See, they again recycle. See the coefficient of friction. See the friend is a inline process of thermoforming we have seen now. Okay. And Now I am going to show you the we'll start the new topic, that is the a foaming process, right? How the foams are manufactured, thermocols are manufactured, how what is their application. We're going to see now uh, the foaming this thing. Is it visible to you? I have shared the one slide. Hello, hello.
Yes, sir, it's visible, sir.
Yeah, yeah. Now I am just starting the other topic, that is a foaming. How the foams are manufactured, right? See, foaming of the plastics. Now you know that where the foams are used, right? I have a one just video, just you see the application of this foaming place, friend, so that you will get the more idea. See, now these are the all foams, and we will go in details now. See their application first. If you see the application, see the temperature, temperature resistance, insulation. These are the main property where we are using the foams, right? In a refrigerators, see now the plastics we are using foam for temperature resistance, for energy absorption, for recyclability, and there are many things, friend, right? So these are the application: insulating foams, flame retardant foam, bio-based foam, structural foams. See the particle foams. See the particle foam is like this. See, these are the granules for the automotive foaming, extrusion foaming process, direct continuous extrusion, then pre-forming process. See here, autoclave forming. This is the one process by which we can manufacture the foam. Then extrusion foaming. This is also another process. We can manufacture the foam. Pre-foaming process. Yes, it is a possible. Then this is a product. It is a continuous type of foaming process. Now here, see the direct continuous extrusion now. We can see here. See, all these things are made from the foam only. These are the main property of the foam actually, frame, insulation, flame.
So you're talking about forms, right? There are different types of forms. So which
Yes,
forms
yes,
you're talking
yes,
about right
yes,
now?
yes, yes. You will get detail. Don't worry. All things
Okay.
I'm going to cover here. See, this is a foam, trains, sheets, films, insulating foam that is using for the our refrigerator, hybridization. This is the morphology actually to change the size, shape, and the structure of the polymer. See, these are the things, friend. Very important things are there. How the how these are manufactured. See now, see the flame now here, halogen free EPS flame and EPS without flame retardants. See, it is now burning, but this foam is not burning. There are structural foam also, PET foams also from the recycled polymers, structural foams, high temperature foams. There are different type of foams actually. See the size here, micron, 500 modification of technical polymers. Friend, I was showing you, see, this is the basic idea about the thermoforming. Now I will show you where these foams are used in the market, day-to-day life, where we are using these foams. Okay, I have done second video here. We just go through this video. You will get where the polystyrene foams. See, these are the loops. See, in the winter, summer, you can, use this. Yes.
Which application we can use for winter, summer? I
Yeah,
didn't get
yes, yes. Winter, summer, both.
which product. Which product? Sorry.
Yes, winter, summer, we can use. Arey, very cool. Very. If you see the summer, that places, you can save. You know, nothing will happen. You have to do the flame retardant. You have to add there in the foam, and you can use that foam for the construction purpose. Construction.
Okay. Okay, you mean to say that roof? I can say sheet metal forming below
These
forming.
are
They are
these are
using the
all
form, right?
polystyrene. Now, see, there are different type of material frame
Is
we
it
can
is it
manufacture.
same? I think it's a PU form we are using that and top roof that sheet
Yeah,
sheet
no,
form.
even polystyrene also you can
Okay.
manufacture. This is a can be used for for many application. Polystyrene, if you see even that for all the equipments, that glass equipments, many sensitive parts, electronic part. There are number of, see now, see I am going to cover everything. You can also now, I advise you people now, right? You can set up a very small plant of manufacturing the granule, the foam, that foam of the polystyrene, styrofoam, right? You can manufacture, friend, at your place also, right? In your house also, you can just do the, that laboratory. I will show you that all video with me, and you can open your own business, right? And you can sell that. You can export that, friend, right? And you will get, that raw material also very cheap in India, right? And you can make your own industry, maybe, and the government also giving you subsidy, maybe 40 to 45%, right? Only the 60% you have to add, right? And the government will give you free hand, because this government, that for they want to open, that a new starter, right? And definitely this is a one type of opportunity. You can set up your own plan of farming plan, right? And now if you, after this lecture also, you can ask me question. I will definitely give you, friend, this is a very foam manufacturing is a very there are process how to manufacture the foams, right? Sheet foam, rod foam, any type of foam you can manufacture the foam, friend, right? Now before starting this, I will just show you again. This is a one video again, just to see this video. See where it is used, right? Where these foams are used. Expanded polystyrene. See all the fish atoms you can preserve. See, these are all raw material preforming. These are the methods here, friend. Raw materials. See, these are raw material granules of polystyrene. See, beads. These are the beads. See now, these are the beads. Right. And the beads are, it is a autoclave. And you will, steam is generated and it
Sir, you
injected
shown
into
the
the,
bead, white color bead. Is it the same bead which you are using in bin bag? Hello?
yes, friend. You are saying something.
Is it same white that bead we are using in bin bags?
No, I'm not getting you because of this sound. I have, this video.
Generally,
1 minute.
bean bags.
Yes, we will discuss afterwards. Just let me show you this video
Generally,
first. And see, these are the application, friend, right? All the even housework also, construction of the house. These are the beads. I will tell you. This is having a diameter only 1 millimeter, friend. Very small one. And see now how the diameter. Is a preformer here.
What is this material, sir?
Just 1 minute. 1 minute. You can slice as a bread. See now, see these are the cutters here. You can cut easily. And see, this is for insulation. Insulation, you know that any you know that a top floor person, they can use this. Only 2% EPS and 98% year only, friend. Let's just check up that. See how much diameter will increase. Therefore, friend, we will see this, tomorrow, and we'll go in details here, friend. Just I have shown you this one to two video to you, three video about the applications, and we will go detailed process how it is manufactured, where are the applications, what are the advantages, disadvantages. There are many materials by which we can manufacture the foams, right? And these
What is
where these
EPS,
foams
sir?
are used, how they are manufactured. We will see everything in this lecture.
What is EPS,
Now
sir?
tomorrow, hello. Am I audible to you? Hello.
Sir, what is EPS? EPS, what is EPS?
Expanded polystyrene. Expanded.
Okay.
See, only two, that one mm diameter become a, 98, mm diameter. Very big one, bigger one. See the expansion of this, expanded EPS, very high. And there is only 2% material and 98% year frame, year, and see this foam, it is and I will tell you how it is recycled also afterwards. But looking these three videos, you now got some ideas about the application where we are using this, right? Even the people are using the POP in their house. They're also at that villages nowadays. People are using this type of foam sheet to get the cool atmosphere in the house, right? They are using the cement, that this thing, and after that, below that, they are doing the POP, and in that POP, they are using this thermocol sheet. Now, friend, we will discuss details tomorrow. Happy New Year to all of you, and tomorrow we have a holiday actually. Hello,
Yes, sir.
hello.
Understood.
Tomorrow there will be no lecture. We will meet, on the second of the January. Okay.
Okay. Sir, one small, yesterday I asked for the yesterday's first 1 hour slide. Just you can fast go. This is you don't want to explain also. Just I want to see the last few slides, sir. That's all. What
No,
was yesterday's the first 1 hour? I asked yesterday itself. You told today you will be showing. Just you can no, wrap up fastly. You don't want to tell also anything. Just fastly you can wrap up.
which one? I'm not getting now. Hello.
Yesterday's first 1 hour class, I've not attended. If you can just show me what all the content it was, that will be helpful for me. That's it.
That is of the thermoforming. Hello.
Yes, yes, sir. Yes, sir. Yes, thermoforming.
1 minute. You are. Should I share you now? Hello.
Yes, sir. Yes, sir.
1 minute. 1 minute. I will share you now. Just 1 minute. Because today is that 31st, and many hello.
Yes, sir.
Hello. Today is the 31st. That's why many of them want to go. Can I show you on the that day after tomorrow?
Sir,
Hello.
you can show me within 1 second. One slide is also okay, sir. Because I have one recording system.
Yeah.
I can see it afterwards.
Okay.
You
Okay.
fast wrap up is okay. One
But
slide, 1 second also it is
should
okay.
I show you today or maybe day after
Yes, sir.
tomorrow?
In another 2 minutes, you can show fast, sir. That's enough.
Okay. 1 minute. 1 minute. I will just checking up. Just 1 minute. Because time is over.
Understood.
Many of them, they want to leave the place, and today is the last day of the year. And there will be no lecture tomorrow. We will again joining on the 2nd of the January. Okay. Hello, is it visible to you? Hello.
No, sir.
Uh, no. I share one slide. Is it visible to you?
No, sir.
No. One minute.
It is not shared so far.
1 minute. Hello. Am I audible to you?
Yes, sir. Audible, sir.
But what happened? The sharing option
Ah,
is not getting. 1 minute. See, sharing option is not. I'm not getting now because time is over now. That's why I am getting link from the other department. Hello,
okay.
and now they maybe stop sharing. Right.
Okay, no problem. Thank you.
Well, okay, no, not to worry. I will. You remind me on the 2nd January.
Yes,
Definitely,
sir.
I will show you. Don't worry. Okay.
Okay, sir.
Yeah.
Thank
Yeah. Good night and Happy New Year to you.
Happy New Year, sir. Happy New Year, all.
Yeah. Happy New Year to you.
Thank you, sir.
Yeah.